Consider the following game that involves tossing a fair die. If the outcome of a toss is an even number, you win rupees 2. If the outcome is 1 or 3, you lose rupees 1. And if the outcome is 5, you lose 3. What are the expected winnings? So these types of problems, there is two random variables. So first we have to find the random variables for the probability. That is, since it is a fair die, it has total 6 faces. That is, x is equal to 1, 2, 3, etc. 6. So probability of getting x is equal to 1, that means the die has only one face with number 1, therefore its probability is 1 by 6. Similarly, the die has only one face with the number 2, so probability of x is equal to 2 out of 6, that is 2 by 6, out of 6, that is 1 by 6, etc. Probability of x is equal to 6, its probability is also 6. So this is the random variable, that is x is equal to 1, 2, 3, etc. 6. Now, what is y? What is the role of y here? Here 3 possibilities. One, that is loss rupees 2. Another is that is not loss, this is win rupees 2. Another is loss rupees 1, and third one is loss rupees 3. So for winning we take plus, and for lose we use minus. So the random variables of y we taken as -1, -3 and 2. So our aim is to find the probability density function for y. That is, let y denote the amount you win in one round of the game. Then y is the random variable with the possible values in the set is y. That is we taken as sy. Sample space notation is we taken as s. That is the sample space of y, that is sy is equal to -3, -1, 2. So what is the probability of getting -3? What is -3? You lose 5. You lose 3. When you will lose 3? If the outcome is 5. So probability of x is equal to y is equal to -3 means while tossing a die, your outcome is 5. So what is the probability of outcome 5? Its probability is equal to 1 by 6 from this one. Now what is the probability of -1? When you will lose rupees 1 if the outcome is 1 or 3. So what is the probability of getting 1 or 3? For probability of getting 1 or 3, or means this is independent event, so getting 1 or 3 means you just add the these probabilities. That is probability of x is equal to 1 plus probability of x is equal to 3. From this relation, probability of x is equal to 1 means 1 by 6 and x is equal to 3, that is also 1 by 6. Total value is equal to 2 by 6. Now the last one, probability of y equal to 2. When will we get to y is equal to 2? That means when you win rupees 2, that is you win rupees 2. When will you win rupees 2? If the toss the outcome is an even number. What are the even numbers here? 2, 4, 6. So probability of y is equal to 2 means probability of x is equal to 2, x is equal to 4, x is equal to 6. These are our condition and the independent event, therefore we can add directly probability of x is equal to 2 plus, probability of x is equal to 4 plus, probability of x is equal to 6. Total 1 by 6, 1 by 6, 1 by 6 equal to 3 by 6. Now we can rewrite this random variable or PDF function, that is y and p of y. What is y? Y is -3, then -2, minus 1, then 2. What is the probability of minus 3? Y is equal to minus 3. That is we calculated as 1 by 6. And what is the probability of y is equal to minus 1? It is equal to 2 by 6. What is the probability of y is equal to 2? That is equal to 3 by 6. So this is the new probability density function for y. That is P of y, that is 1 by 6, 2 by 6, 3 by 6. Now what is the expectation formula? Expectation is expectation of y equal to summation yi P of yi. So when you take the first value, you take the corresponding probability. So first value is equal to minus 3 into its corresponding probability, that is equal to 1 by 6. So minus 3 into 1 by 6 plus the second value is minus 1 and its corresponding value, that is equal to minus 1 into 2 by 6 plus 2 into its corresponding probability, that is equal to 3 by 6. So while simplifying, you can get 1 by 6. So this is the expectation winnings. So this is our required answer. The value of random variable x are integers from 0 to 6. The table below gives the cumulative distribution. At each of these values, find the probability, mass function, mean and variance of x. So this is the direct question, directly given the probabilities and its cumulative function only given. So from this we have to find the probability, mass function, that is PDF, then mean and variance. If probability cumulative distribution is given, first idea is to find the probability density function, because for mean and variance we take the PDF only. F of 0 is equal to 0.05. You take the first value. Then what is f of 1? Since the given function is cumulative, you subtract the first value from the second one. That is f of 1 minus f of 0, that is equal to f of 1 is equal to 0.20 and f of 0 is equal to 0.5. Why we have to subtract? Because the cumulative function is, for first one you keep the first one, for second one we add these two, first and second. Third one is we add first, second, third. So the sum only given, but we need the individual values. So for each one you subtract the previous one from its corresponding values. So that is f of 1 is equal to f of 1, capital F of 1 minus f of 0. So you subtract the first from second, that is 0.15. Now f of 2 is equal to capital F of 2 minus capital F of 1 only. Now we write these values in the table. That is, for 0 is 0.5, for 1 0.15, 2 0.22, etc. You can just add this everything, your answer should be 1. Then only it is a probability density function. So here expectation of x is equal to, you take the first value, that is equal to 0, and multiply with its corresponding probability, plus second value and multiply with its corresponding value, etc. So we can get 0 into 0.05, 1 into 0.15, 2 into 0.22, etc. Finally we can get 2.97. What about the expectation of x square? Just take the square of this x and multiply it with its corresponding probabilities. So 0 square into 0.05 and 1 square into 0.15, 2 square into 0.22, etc. we can get 11.47. So the final formula, that is variance of x is equal to expectation of x square minus expectation of x the whole square, that is 11.47. that is the first value, that is 11.47 minus 2.97 the whole square, so 2.6491. This is our required variance.